Hey, it's Laura with Miston Labs, and today we're going to take a look at how to profile a transaction to see the gas execution cost. We're going to do this using the Sui CLI. So the first step is to make sure that we update our Sui CLI and also to install it with the feature Gas Profiler. This is really important. If we don't have the feature Gas Profiler enabled, we won't be able to run the profiler. So let's do this by running cargo install --locked --git https github.com/mistonlabs/sui.git --branch main sui --features gas profiler. After we run this, we also want to install the prerequisite tool called Speedscope, which we can do by running npm install-g Speedscope. This is the tool that we're going to use to inspect the profile. Now let's go ahead and profile a transaction. We can do this by running Sui client profile-transaction --transaction digest and then pass in the transaction digest. Here we can see that we're executing this transaction locally, and for any prerequisites, we're going to pull those from the full node specified in our Sui client environment. All right, so we can see here that gas profile written to the file was written to our local working directory, which you can also override if you provide a flag to the command. But let's see here. Let's open it with Speedscope by running Speedscope and then passing in the path to the file. All right, so now we're looking at the profile. We can see here there's a lot of boxes, and there's 3 different views by which we can view the information. So time order view is going to show us from left to right the order in which the functions were invoked, and then the vertical axis shows us the functions that this top function called into. So if we double click any of these functions, we can see this in more detail, and it will zoom in. And if we hover over, we can see the computation units that were accrued by calling this function. This top section we can use to click and drag. We can zoom back out. And if we head on over to left heavy view, for any function that was invoked multiple times, it will group all those invocations together and sum the computation units and display them from left to right, from most expensive function to least expensive function. And finally, we have sandwich view, which is perhaps the most useful to quickly get a sense of what is the individual function that was the most expensive. And in our case, I've clicked self to sort in descending order to see that add child object as an individual function accrued the most execution cost, which was about 17% of the total execution cost of this function. If we click another function here, we can see basically the sandwich view, which is these are all the functions that called this function, and then these are all the functions that this function called beneath. The values under total correspond to the total execution cost of not only the function, but all of the functions that that function called, whereas the self corresponds to the gas costs accrued by just the code in that given function. If we head on back over to the documentation, we can read more about this in detail. And if we wanted to develop a smart contract and to get a rough idea of how much the execution cost would be for running a transaction to that smart contract, we could do this by running a local network and publishing our smart contract to this local network. What I would then do is to basically send a transaction to the local network that calls my smart contract, and using the transaction digest, run this command right here, so that we can see a breakdown of the gas cost. That's all I had for you today. I hope you've enjoyed, and take care.